Okay, so let's proceed to our second example, guys, which is to determine the ultimate moment capacity of the beam section shown using NSCP 2001 and NSCP 2010 specification. So use 28 MPa and Fy, which is 415 MPa. So if the section carries a service dead load moment of 120 kilonewton meter, so what would be the maximum service live load it could carry? So you may use 1.2 dead load plus 1.6 live load for NSCP 2010 and 1.4 dead load plus 1.7 live load for NSCP 2001. Okay, so this is our beam here. Okay, so as you notice, our beam is a double layered beam. Okay, so into our analysis later, so I think we'll be using values for d and dt as well, no? So I think we need to know those values first, no? Before uh, before we proceed with our solution. Okay, so dt, I think dt is quite easy. So dt is from chapter 2, no? So from chapter 2, I discussed it already, no, last time, that dt is the extreme, the distance from the compression extreme compression fiber to the extreme tension reinforcement. So meaning that extreme tension reinforcement is this one here, this 3. Okay, so I think dt is, okay, so from the centroid of this bar to the uh, compression fiber, okay, extreme compression fiber, so this is dt. Okay, so that is dt. So how we could solve dt? So dt is equal to, that is 800, the height, total height, then minus the concrete cover, which is 40. So that is concrete cover, guys. Now concrete cover is from the extreme fibers, no, extreme fibers of the beam to the edge, no, edge of the stirrups. Okay, that is 40. Then the stirrups is 10 mm, so minus 10 mm. Then we are now here minus 10 mm. Then also minus half the diameter of the bar, which is minus 32 over 2. Okay, so I think therefore dt is equal to 700. Okay, so 734 mm. Okay, so that is our dt, guys. Okay, so now how about for our d? Okay, so again from last time, d is here. Okay, okay, so dt is this one here. Okay, so at the center of the two layer bars. Okay, so that is d. So this is the distance or effective depth. Okay, now how to get d? So d is equal to 800 minus 40, so minus 10. So again, that is the concrete cover, then minus the diameter of the stirrups, then minus 32. Then since it has a spacing, guys, now the spacing between the two layered longitudinal bars is 25. So since that is at the center, so minus 25 over multiply over 2. Okay, so therefore our D is equal to 705 mm. Okay, so always expect that dt is greater than d. Okay, so since dt is until the extreme tension reinforcement. Okay, that is our for d and for our dt. So let me go to the whiteboard. So we have here for number 2, so we have d is 705.5 mm. Then we have dt, so dt is 734 mm. Okay, so step 1, we need to calculate for a. Okay, so a, again I'll be using NECP 2010 guys, no, for the solution. NECP 2010. Again, so a here is equal to, so a is equal to as times fy at the numerator. So this is pi over 4 d squared, then times 6, since there's 6 bars, then fy is 415. So let me put it here. So 415 MPa. Then f prime c is 28 MPa. Okay, so all over 0.85 f prime c, then times b is 500 now from the figure. So this is our b. Okay, so b, therefore the result would be equal to 100. The result is 168.28 mm. Okay, so while c is so that is a over beta 1, 168.28, then 0.85. Again, beta is 0.85 because that is less than or equal, or that is equal to 28 MPa, which is the upper limit. Okay, so this is equal to 197.981 mm. Okay, so that is C. So again, we assume it here guys that our bar yields, no? Since we use 415 to solve for A. Okay, so we will find out later if it yielded, no? So now we'll solve for ET. Okay, so ET is 0.003, then times, we'll be using dt here. Okay, take note, dt, not d alone. Okay, so dt, so meaning we'll be using 734 here. Okay, so 734 minus c, 197.981, then all over c, which is 197.981. Okay, so the result is equal to 0.00812. Okay, for our ET, no, strain T. So again, for ductility requirement, so this is for ductility requirement, so this is greater than 0.004. So therefore so ductility requirement is okay, no? So we are okay with it, no, for ductility requirement. As I think this is also equal to 0.005. So therefore this is tension controlled. Okay, so tension controlled. Then therefore as well here, that our phi is automatically equal to 0.9. Okay, then I think this is also greater than strain y, which is Fy over Es. Okay, so find out what is the value of this strain y, but definitely strain T would be greater than that strain y. So therefore use, okay, so therefore using Fy, therefore using Fy for A is okay, no, or the assumption is correct, no, for this case here. Okay, that is this is good, no, all the requirements were met and tension control and Fy is okay for solving A. So now if that's the case, then let's proceed to our step 3. Okay, proceed to step 3, which is to solve for Phi-Mn. So Phi-Mn, so I'll be using, guys, phi C, then D minus A over 2. So this is equal now to 0.9 then times 0.85 F prime C. Okay, F prime C, then A is 168.28. So let me check. Okay, so 168.28 then times F prime C. I think F prime C is already there. Then prime C times B, no, AB rather, no, 500. Then times D. Okay, so we'll be using D here, not DT. Okay, so D is 705.5, then minus A 168.28 over 2. Okay, then divide it. Okay, divide it with 1000 squared. Okay, so therefore Phi-Mn is equal to 1100, or okay, so 1119.91 kilonewton meter. So this is the moment capacity of your beam, but we are tasked to determine the service live load that it could carry, no? So we have this condition that our Phi-Mn should be greater than or equal to our Mu. Okay, wherein our Mu, guys, is equal to 1.2 moment dead load plus 1.6 moment live load. So I think we have that given already there. Okay, we have that given that our service dead load moment is 120 kilonewton meter. Okay, so our task here is to get the moment for live load. Okay, so in here, so Phi-Mn, we already have value for Phi-Mn, which is 1119.91. Then this is greater than or equal to 1.2 dead load 120, then plus 1.6 live load moment. Okay, so therefore live load moment is equal to, I think this is 609.94 kilonewton meter. Okay, so this is our answer here, guys, for our moment. Okay, so that's all for example 2. So hopefully you learned something from it. Okay, so thank you, guys, for listening, and keep safe, everyone.